just finished the last two battery supports and it's here. I'm preparing to install the support for the batteries. This is the support, but I need to fix this on the hull. To start that, I need some stainless steel plates that I will try to find here in my stuffs. Okay, just cut the pieces here. Can you see? I call this the magical cutting. It's easy. I work a lot and you see, done. Instant rolls. Nice, right? Looks 1 second roll and it was 2 hours. The main battery support. As I show you, I did the plates to fix on the hull, and as you can see, I fix it here. Okay, 6 of them. And I did some supports here, each one with the right size to level the support. It's on the right level right now. And I did the first drops of welding, and now I need to remove that and weld. But it's too late right now. I'm tired. I will do this tomorrow. The plan for the electrical system of this boat is a little bit tricky. Not difficult, but tricky. Why? First, the original system of this boat had two voltages. First, 12, that was used for the lights, the pumps, and all the things that needs for the energy for the boat. And 124 volts to start the engine. This big engine needs 24 volts to start. Well, my plan is change a little bit this. First, I remove the 3 150 ampere hour batteries and install 10 105 ampere hour batteries that will supply 24 volts for the boat. Not for start the engine, for the boat. 2 batteries for the 12 volt system that I need because many things like the water pumps and other things that it is 12 volts right now, then I need keep the 12 volts working on the boat. With time, my plan is, as the things are getting old or broken, I will change for 24 volts. I will keep two batteries 105 ampere hour to start the engine. But first advantage for the system, as I have a big 24 volts for the boat, I can use this 24 as a backup to start the engine if I have some problem with the batteries for the engine start. I will add another independent system, 12 volt system, only for the lights, just for the lights. This is a decision for high efficiency and simple systems. Why that? First, LED lights, almost our LED light is something like this. It's waterproof LED lights, but no driver. It's just the LED. Like I have here, these lights is 5 of these inside. It's very high efficiency, simple and cheap. But when the voltage change or have some variations, the amount of light change, that is not a big issue. We can handle with that. It's not a problem. But if the voltage grow too much and go too high, can damage the LED. We need to keep in mind that when we start the engine, the generator or alternator grows the voltage a lot, 12 to 14 volts. This can damage a LED without driver. When we turn on the battery charger, the voltage can grow up to 14.5 to up to 15 volts. That will damage the LED. We burn the LED without driver. LED need work with a maximum amperage. You need know the specification, okay, to be sure. And you cannot go up of this. If you increase the voltage, the amperage grows too, and this can damage the LED or LED light. And that's why I'm doing a separate system, 12 volt separate system just for the lights. Let me show you. That is my guy. That is a voltage regulator. I can take 24 yes, it's something like I can input 21 to 30 volts, 32 more or less, and this voltage regulator will give me 12 volts on the output, exactly 12 volts. That is the perfect voltage for this kind of LED. I have some big LEDs I will not show right now, 50 watts, not 15, 50 watts each one. I install 2 each mast. We have 2 masts, means I have 4 to lights the deck, the outside of the boat. This voltage regulator is able to run, let me check here, yes, let me run 40 amps, twice that I really need if I turn on all the lights. That is safe. Then these 12 volts is separated, that 12 volts comes from the 24. Why I'm doing this? Again, to stabilize the voltage and to have a very high efficiency on the system. The standard lights for boats that can handle with big voltage variations is have a driver inside. We call, depends the type of the light, but almost everyone is up and down, step up and down. Inside means have a step up and then a step down voltage regulator. The step up takes the 12, some variation of the 12, 11, 12, 13, 14, 15, and change to something about 20, 22, 24, and then have a second regulator that brings down to the right voltage, 12. Okay? These 2 regulators lose a lot of energy. First, because stepping up is less efficient. Typically is about 80 to 19%. And stepping down, if it's too good, is about 95%. This regulator here is a stepping down and is about 25 to 26% efficiency. If I want a standard one, a standard LED, a standard light with inside driver, the efficiency is no more than 70, 75, no more than this. Then you lose a lot of energy heating the voltage regulator. I don't want that. We have a lot of light here, and I want to keep this with high efficiency. 24 volts will run the high consumption equipments. The 24 volts main system, I will keep the high power things on the boat, like the inverter, like the fridge, the freezer. We'll have 2 fridge systems and air conditioner, things like that. Things that need a lot of power. Right now the pumps is 12, in the future I will change to 24, but the inverter is 24 for 2 reasons. First, 24 volts input for the inverters, the efficiency is higher. I'm talking about 2 or 3% more efficiency than the 12 volts. Second, as you have the double of the voltage, you have the half of the amperage. If you decrease the amperage, you can have thinner wires, and the energy waste on the wire is lower, and it's a better system. And that's why I'm choosing the high power systems running in 24 volts. Another reason for the 24 is because I want a large... We don't have energy generator here, a diesel energy generator here. It's just our diesel engine and the solar power. In the future, wind power too. We don't want to install the generator. What I'm doing is installing a very big 24 volt generator on the engine. This is a truck generator, a big Bosch generator, is amazing, that can supply 24 volts and 140 amps. It's something about 4.6 kilowatts of energy. It's a lot of energy. And I cannot find 12 volts alternator or generator with this kind of power here in Brazil. And as I'm doing with 24 volts, the amperage decrease. If I have, just to have an idea, if I take the same generator, same alternator with 12 volts, the amperage goes to 208 amps. I needed the twice of the wire, and the losing in the wire can increase. Then it's better work with 24 if I need high power, high amperage on the system. And with the 24, I can run a simple stepping down regulator with no problem, because stepping down needs voltage higher than the output. The input need be higher, at least 2 or 3 volts higher than the output. If I want a 12 volts output, I need at least warranty 14 to 15 on the input. And the 12 volt system, I have variations, can be 12, 12.5, 13 or 14. In some cases, when you are charging, fast charging, you can go up to 14.5 or 15. If I change the batteries, lead-acid batteries, to lithium batteries, the voltage increase a little bit, and with this system I can change the type of the battery without problems with the lights. Then the 24 give me these advantages. Epoxy on the bottom, okay. The battery support, okay. Now I will try to install that. Let us see. Do you think it's hot today? Just an impression. It's done. The first battery support for 8 batteries. I need do more. I need do 2 extra supports. One there for 2 batteries, and another here for more 2 batteries. More work. Just finish the last 2 battery supports and it's here. A little bit complex. Because the shape of the structure of the boat, but it's in level, and now I need to do a bottom painting, white bottom painting, just to protect the wood, and next day I can install. I have too much to explain about the electrical system, much more about our solar system and how I'll charge, how I'll control these little guys here, but it's too much information. Then I will explain in the next video.